already the solution for 애로-드부루 securities like this. So you can just copy and paste this one. So if I run, then I have 애로-드부루 securities like this. So this is the code for 애로-드부루 securities. So I start from I equal 1 to n, and j start from 0 to I. Okay, and then ji, so cell n minus j minus 1, I plus 1. Is also p multiplied by going up. Going up is a cell above, so it is n minus j minus 2 because it is above. Okay, and then 1 minus p multiplied by now same row n minus j minus 1, and of course for column because we move it was a forward because it's a forward induction. So I use the previous column, numbers in previous column to find the next column. And then, of course, I have to discount it. So this is it. You can try. So the price of 애로-드부루 security, which is paying like $1 at this particular state, when underlying asset reaches 94, around $94, then what is the value of price that pays $1 when stock price becomes exactly this one? That is the like 0.286411 dollar. And then derivative, underlying asset, those things, clean. And then if I change this one to, maybe I can make a larger tree. So let's make it 5. So let's make a tree size 50. Okay, 50, and if I run, okay, and of course I have a huge 애로-드부루 security like this, very large one. Okay. It is quite large. Okay, so do you understand what is going on 애로-드부루 securities? Is important thing. So no problem. So I provided you code with code. So actually you have to understand what is going on. So you said it's okay. So I make a filter from the bottom, okay, and then stack. And today, and then we actually about derivative pricing. Okay, we learned the Black-Scholes formula. Black-Scholes formula to calculate European full option and European call option. We are done. And then we learned binomial option pricing model. Basically, you can price any derivative as far as underlying asset is just one, and the interest rate is fixed. And then there are a third way. Actually, there are a lot of ways, but there are another very flexible and interesting way of doing derivative pricing. It is by simulation. Okay, and we learn how to price derivatives using simulation. And before we learn that method, basically we have to. I think it would be useful if we do some practice with Excel about how to generate a random number. Okay? When we generate random number, the most basic one is uniform distribution. Does anyone know what is uniform distribution? What is uniform distribution, Nicola?
I think it's when every number is the same probability of getting number.
Yes, exactly. Any real number, right? So the simplest one would be look like this. Okay, so and then let's pick 0 and 1. And suppose I'm interested in generate random number between 0 and 1. And what I want is I want any real number between 0 and 1 is generated exactly same probability. Same probability. Then the probability density function will look like this. Right? Density function will look like this. Okay. Right? It will look like this. I mean, it is in some sense natural because I want every number between 0 and 1 should be generated exactly same probability, so probability density function will be flat. And then the size of this area should be 1. So the height should be 1 as well. 1 by 1, 1. So it is a probability density function for uniform distribution. Then what would be the probability cumulative density function for uniform distribution? CDF, cumulative density function. What would it look like? So it is a probability density function. Huh? Yeah, cumulative. Yes, exactly. So let's think about it. So it's a PDF. This is cumulative density function. So let's pick this number. For example, this is like 0.3. Then cumulative density function means the probability that I will pick a random number that is less than equal to 0.3. Right? And the size is this area. Okay. Then the probability is the size of this area. Right? Okay. This is the probability that I generate random number less than 0.3. Okay. Then what would be the size of this area? Size of this area is again 0.3. So for 0.3, the probability that random number is less than 0.3 is 0.3. Okay. 0.3. When I pick like 0.9, okay, 0.9, probability that random number is less than 0.9 is again the size of this area, so 0.9, and then, okay, 0.9, okay. So cumulative density function will be like this straight line, and then this is 45 degrees. 45 degrees and straight line up to 1. And then probability that any number is less than 2. Okay, 2 is 1, right? Still 1. So it should be flat. Oh, yeah. It should be. Okay. and it should be flat from this point. Okay? Flat from this point, and it should be flat from this point. Like, because the probability that a random number is less than like -1 is 0, right? Because every random number is between 0 and 1, so it is 0. So the cumulative density function will look like this, right? And then PCDF, probability density function, is of course look like this. This one, this, and this. Right? Okay? And this is a basic, okay? This is the uniform distribution is a basic, and then we will gonna generate it like a normal random number from normal distribution using this uniform distribution. Okay, that's our idea. And then using Excel, then how to generate a random number, okay? Uniform distribution. In Excel, we have a very simple function which is called this one, rand. Okay, rand this one. Okay, so and this one will be, this is they are all random numbers between 0 and 1. It is drawn from uniform distribution. It is very simple. It's a rand this one. Why don't you do it? I mean, you can do it. And then if I press F9, then it is refreshed. And then let's check what would be the average. What would be the average of this one? What do you think is the average of this one? 0.5, right? Let me see. It is not exactly 0.5, so it should be, if I generate enough number, it should be 0.5. What would be the variance of this one then? Can you guess? What is the variance of the uniform distribution? 1. Why? So, okay, let's calculate. Okay, let's check. What is the formula to calculate the variance? Yes, so EX square minus EX square, something like this, right? This is one way. So let's calculate. So we know EX square, right? EX square is what? EX square is, in uniform distribution, EX square is what? What is EX square in uniform distribution? Right? And then, therefore, we can just calculate this one, right? And then this one is, I think, okay. And then, of course, we have to do the integration, right? In order to calculate variance, we have to calculate integration. And, okay, we have to do the integration from basically minus infinity to plus infinity. But minus infinity to 0 is all 0. Probability density function is 0. And then 1 to plus infinity is also 0. So we then have to do integration in that area. So we can do the integration between 0 and 1. And then EX square, so U square, okay, U square and F U du, right? That's the EX square, right? And then we know basically FU is basically 1, right? It is 1. So we can calculate just this one. And then in what is this one? It is the it is 1/3, right? Right? I mean, it is the 1, 0, right? Then it is what? It is 1/3. Am I right? Right? It is 1/3. 1/3. So this is basically, okay, then it is basically 1/3 minus 1/4. right? So it is 1 third. So variance would be look like this. So okay, so which should be equal to, okay, so yes, variance is a lot similar. Then so mean should be 1/2 and variance should be this one. So I mean it moves around that number. Okay. So is it okay? So this is rand. Please remember this rand function. It is a very important function. And then okay, next let's think about how to generate now random natural number. Okay, suppose we are interested in drawing random number between 1 to 100. Okay, suppose we are interested in generate a random natural number between 1 to 100 with equal probability. Then what would be your idea? So I don't want to generate number like 1/3, 1/4, something like that. I want to generate number like 1, 2, 3, 4, 5, and 99, 100. But each these 100 number with equal probability. Okay. So it is random natural number between 1 to 100. How can I do that? Do you have any idea? Felix, do you have any idea? How we can generate random number between 1 to 100 natural number with equal probability? Yes, what is your idea? Multiply this on 100?
This is the range
Okay, then,
to 1, right?
yeah, 0 to 1, but problem is that, okay? Okay? If I multiply, that is the, okay. If I multiply 100 to this one, yes, then it is the uniform distribution. Okay. It is uniform distribution. I generate any random number between 0 to 100, right? That's correct. That's definitely correct. But then I am interested only random number, random natural number. Okay? Not real number. Okay, then how can I do that? So they are all real number, right? But I just want to make it 1, 2, 3, like 100, something like this. Then how can I do that? Well, it is, I think, a good start. Then how we can
I already saw in German Excel that there is something like you can have random number or random interval, and you can set the limit.
yeah.
But I don't know what the English.
Yeah, but I mean, there in Excel there is a function that do that work, but without using that Excel function, I mean, let's think about it. Let's use this uniform distribution and generate random number within 0 to 1. How can I do that? I mean, let's use our brain instead of just Excel. Okay. Any idea? Okay, it is a good start. And then what if we do the round? Okay, if we do the in Excel there is a function for the round, it is a round up or round down, something like this. Digit 0. Then yeah, something like this. Then do you think it is right? No, because there is a 0, right? I don't want 0. I want number between 1 to 100. Okay, so round is a good. This is good start, and rounding this one is a good one, but then this one doesn't look so nice. Then how can I do that? Okay, then actually it is not simple. Okay, let's think about it. Okay. Okay, so from 0 to 100, then I can make this one 100 interval, right? 1, to 99. Then I have this interval, and I have another this interval, and I have this interval, something like this. And then I have this interval, right? Right? And this interval. Then what the idea is that we generate a random number between 0 to 100, maybe. 0 to 100. And then if a random number is drawn from here, I call this is 1. And if a random number is in this area, I make it 2. This area 3. Okay, then this area is 100. Then it is done, right? Always round up. Okay, so always round up between 0 to 100. So in Excel, there is, I think, round up, or there is a function called the ceiling. Ceiling, but 100. This is ceiling is not right. Round up, or maybe round up. Round up. I think this is right, right? Yeah, there is 101. So I think this is, so I'm ready to rounding up any number. Okay? And then in the case, at each interval, it is assigned as 1, 2, something like that. Right? Simple. Okay? In Excel, actually, so this is the one method. But in Excel, there is another function called actually rand between. Okay? That's even simpler. So rand between. So now 1 to 100. Then it generates random natural number between 100. So in Excel, rand between do this work. Okay? And basically it is same to rounding up a random number between 0 to 100. Right? So it does exactly the same. Okay, any question? 질문 있어요? No. Okay. I have another question. Now, suppose I'm interested in this number. So, okay. Let's do more brain exercise. And then suppose I'm interested in random number, like this area, and then this area. So let's say this. So in that case, let's say this is 0 to 3, and then 7 to 20. Then what is 3 and 13? 1 over 16. Height is 1 over 16. So this is the very weird probability density function. So it means that any number between 0, 3 and 7, 20 has an equal chance of, okay? I have an equal probability of generating any number between this one and this one. But then, I mean, if it is just a flat line, then it would be easy, right? I can generate a random number and just multiply 20, and I can generate a random number like this one. But I don't want to generate random number between 3 to 7, okay? I want to generate random number between 0 to 3 and 7 to 20, but not this area, okay? But with equal chance, then how can I do that? Any idea? Any idea? One by one, but would it work? I mean, then how can I choose one?
Just make it from 1 to 16 and declare that it's above 3, you have to add 4.
Exactly. That's one idea. Yes, that's a very good idea, right? Do you understand what Nicholas just said? What he said is that, okay, instead of generating random notation, we can generate random number between 0 to 16. Okay? And when a random number is between 3 to 16, we can just add 4. Okay? Then it's done, right? Very good idea. Yeah. Good. That's exactly what I'm thinking of. Maybe another idea is that I can generate random number between 0 to 20. And then when a number is in this area, I can just throw it away. And I do it again. Okay? That's another idea. Well, there are many ways doing that. Okay, then let me try another one. So suppose we are throwing a coin. Okay, we are throwing a coin. And then when head occurs, let's call it 1. And then when tail occurs, let's call it 0. So basically, I'm simulating random number 0, 1, 0, 1, something like this. It is called a binomial random number, right? How can I do that? Any idea? So I mean, I want to generate random, yes, with Excel. So when I draw coin, head, I write down 0. I write down 1, and tail, I tell 1. So I can draw coin and write down that number in the Excel, either 1 or 0, something like that. But I want to do that with Excel. How can I do that? Yes, it's a Bernoulli distribution. In Excel, there is actually, I think there is a Bernoulli distribution. Let me check. Bernoulli, binomial Bernoulli distribution. Anyway, I cannot find the Excel function for Bernoulli numbers, but then basically we can do it with Excel. Okay, we can write the code. How can I do that? Any idea? More generally, let's say the coin may be unfair. So probability of head is like 70%, and probability of tail is 30%. And when head occurs, I record 1. When tail occurs, I write 0, something like that. Then how can I do that? Okay. 0, 1, so random 0, 1, 0, 1, or something like that. Okay. Any idea?
The number is greater than 0.5, then just make it 1 less terms.
Exactly. That's a great idea, right? So let's think about it. Okay. So Taewoon's thought is that. Okay. Then Taewoon's thought is that. Okay. So it is between 0 and 1. I can generate random of 0 and 1. And then let's call this area P. Okay, when I generate a random number in this area, okay, this is maybe head. Okay, head. And when this area, it is T. Actually, this area and this area, right? So I pick the P when random number is greater than in this area. So the size of this area is 1 minus P, and the size of this area P, right? And then so this area is, I call it 1, and the other area I call it 1. This is exactly what I'm talking. And then how we can do that in Excel? Pretty simple. Okay. First, I can generate a random number, right? And then let's say P is 70%. If this is less than 0.7, I call it 1. otherwise 0. Right? So, okay. So let's average. Average would be like a 70%, right? Around, but not exactly 70%. Because I have two small random numbers, right? But it is around 70%. Good. It's interesting, right? And then since we just simulate Bernoulli distribution, then when we can run binomial distribution as well, right? Binomial distribution is basically I throw coin like n times, right? N times. And then it is the, yes, so in that case, it is the number of, like heading, number of 1, something like that. Okay, this is called binomial distribution. So since we run Bernoulli distribution and we add this one multiple times, okay. So this one plus, okay, you can do this again, okay. Then it's a binomial distribution again. It is a binomial distribution. Then I throw coin 3 times, and then this number is how many times I have head instead of tail. Okay. So sometimes it is 0. It means that I throw coin 3 times, but every time I have 0. I have a tail. It is very rare because the probability of head is 70%. So the probability of this one is 0.3, 0.3, 0.3. So this is the 0.0021, 27, right? So it's very rare, as you can. Yeah. Yeah, exactly. So it is like up. 3 is up, and 3 is a lot frequent. So it is 7 multiplied by 7 multiplied by 7 divided by 1,000. Okay. Well, this is cool, okay? And then now the difficult part. Oh, actually, now let's write down now the code, okay? VBA code to generate this ransom number. In Excel VBA, let me add. Actually, I can write. Let me write down another code over here. No, let me, I'll add another module. Okay, module 2. So, solve random number exercise. So in Excel VBA, we can use this function. Okay, cells 1 is like rand. I think R and D. Okay. So I click this one. Yes, I have this one, right? So in Excel VBA, it is simply instead of R and D, this one, we can use R and D. Okay, rand. This is the function for. So if I want to generate 100, okay, if I want to generate 100 uniform distribution, then of course I can use 4th sentence, right? So for I in 1 to 100, 100, then next time if I run this one, yes, I have 100 random numbers. How about I want to generate 10,000 random numbers? Then I can simply this one, okay? Another one is I can make a rectangle. So for J 1, 2, 100. For next J. Okay, and if I do this one, it will take time. But basically, I have a 10,000 random number, okay, in rectangle structure. Okay. And next is the very important one. How we can generate a random number from standard normal distribution, right? Now this is the hard part. How you can generate a random number from standard. Are you doing some exercise? Okay. Are you doing some practice for? Oh, it's not. Oh, you don't have a second row for you have J, but where is the J? You declare J as well. Yeah, so in your case, yes, you are missing the second, this one. Yes. Is everything okay? 김지 학생 잘 되고 있어? 예? 이시 해보려고. 네. So next, okay, we want to generate random number from standard normal distribution, and then let's think about what would be standard normal distribution would look like. Okay. So standard normal distribution will look like this, and mean is 0, okay, right? Something like this. And then for standard normal distribution, I want to generate a random number such that I want to generate a number around this area is more likely. Random number this area is center will be more likely than in the tail, right? And then so as we move to the center, we are more and more, the random number is more likely to be chosen. And then we are moving to the tail, random number is less likely to be chosen. So, and by the way, from the definition of standard normal distribution, since it is continuous distribution, so any random number between this area, A, B, any random number between this area should be chosen the probability of the size of this one. Okay, and then of course the entire size is 1. Okay, and then how we can generate a random number like this? Actually, this is not easy in some sense. So we have to be slightly smarter. Okay, so it is a probability density function. So basically, we have to do cumulative density function. Okay, cumulative density function for standard normal distribution would be look like cumulative density function is always between 0 to 1, right? Because this is the size of the, if we pick some t, okay, some t, then the cumulative density function means the size of this area, right? So if we pick t around here, t is 0, and the probability of the size of this area, let's say like 0.6, something like this, okay, somewhere like this point. And then if we pick this number very in the tail, then it will be close to this one, right? 1. And then we pick number exactly 0, then what is the size of the cumulative density function? Yeah? Yes, 1/2, right? Right? Because exactly 0, the probability that a random number is less than 0 is the size of this area, and it is symmetric. This is exactly half. And then for number like this one, and then the size of this area would be small, right? Probability that a random number less than c would be very small. The size of this area, so like this. So if we connect this one, then it would be rule like something like this, right? And this is 0 and this is 1. Okay? So this is not pretty. So cumulative density function for normal standard normal distribution, okay, image. Yeah, so it should be look like this, right? Cumulative density function. So this is the x1. So probability that is less than. So basically, the height of this one is a probability that a random number is less than x1, and the height of this one is a probability that a random number is less than x2. Okay, and then the height of this one. So from the height is entire area is 1, right? This height is 1. So if we subtract from 1, we subtract this one, then it is the length of this area, right? Length of this area is, since the length of this one, height of this one is probability that a random number is less than x2. So basically this one should be probability that a random number is now greater than x2, right? Natural, right? So this part is probability that a random number is less than x2, and this part is probability that a random number is greater than x2. So it is 1 minus fx2. Fx is the cumulative density function. This is fx, large fx. Now another interesting one is actually this one. Okay, this one is the length of this one. So this one is probability that something is less than x1, and this is a probability that something is greater than x2. Therefore, this segment, the length of this segment should be probability that a random number is between x1 and x2, right? Well, it is all high school. I think you learned this one. How about German high school? Did you learn this one in high school?
Might be orange and possibly American. I was student abroad.
Okay. So anyway, you understand, right? And then the idea. Oh, okay. By the way, from 0 at point 0 is equal to 1/2. Okay, right. And then our question is how to generate random number. Okay, random number from standard normal distribution. The idea is look like this. First, we generate random number from uniform distribution between 0 to 1. Okay, so it is basically two-step procedure. First, step 1, we generate uniform random number from uniform distribution between 0 to 1. And then, okay, 0 to 1. And then next, we find the inverse image of standard normal distribution. So suppose we generate random number like 0.8, then we find inverse image of this one, and we pick this one, x2. And then we pick a random number such that like this one, then I simulate this one. Okay. Then the idea is basically if we do this one, so I generate a random number from this area, and find the inverse image of this one. Then this shape is looks like this. So if this number, okay, like these numbers would be very unlikely because it is in tail. So in order to generate some random number greater than this area, then I have to generate random number exactly this small area. So it is very unlikely. And then if I want to generate a random number between this area, it is in the center. So that random number is more likely, right? Because it is, if I generate any number between this area, it is fall between this and this one, right? So if I find the inverse image, then it is in some sense very, we can generate standard normal distribution. Is it okay? So, okay. See the random number MATLAB with Excel. Box-Muller transformation, okay. In Excel. Okay, two ways to calculate random number from normal distribution. So in Excel, basically, in Excel there is basically norm dot inverse function, given probability norm and okay. So thing is that first I generate a random number, okay, and then I find the inverse image of this one. In the Excel, the inverse function of cumulative normal distribution calls norm, standard normal distribution, and inverse. Normal distribution and S means standard distribution, and IMB is inverse function. And then this one. Okay? So for this one, I generate this number. Okay? And then I do it again. Okay? This is the random number from standard normal distribution. So norms inverse and then rand. So I can do it with one step. So norms inverse and rand. This is one step. I generate a random number from standard normal distribution in one step. Okay, something like this. Yes.
This one, we have something like 50% probability, which is 50. It might go on either side, right?
Yeah.
So why does it choose 7 to the negative and why sometimes the positive?
Yes, because it is 1/2. So basically, if I simulate a random number from this area, then it is the positive. It generates positive number from standard normal distribution. If I generate a random number in this area, uniform distribution, then it generates basically a negative number from standard normal distribution. Yeah? Yeah, it is. This one is a cumulative. So yeah, this is a cumulative normal distribution. Yeah, so yeah, this is cumulative normal distribution, and I pick a random number between 0 to 1 and find the inverse image. Yeah, that's the thing. I mean, this is actually a very general way. It's not only standard normal distribution. For any distribution, we can find the inverse function of cumulative density function. We can generate a random number exactly the same way. This can be any arbitrary cumulative density function for any arbitrary random number. Okay. So this is actually mathematically easy to prove. So this is actually, this is actually very general result, such that let's think about cumulative density function. Okay, let's say, okay, p some random number x is less than t is less defined, t is known as ft. Okay. Right? So ft is cumulative density function, right? Right? This is called CDF. Right? So the probability that such random number is less than equal to t is ft, so ft is very good. So this is ft. Particular ft for standard normal distribution. And then if we do the f inverse f t is what? This is t, right? Right? By the definition of inverse function. Right? So f inverse f t is t, right? Right? But I mean in the uniform distribution, u t is t. Let's say u is cumulative density function, right? Cumulative density function of uniform distribution, right? It is 45. It is for cumulative density function of uniform distribution. It is 45 line, right? Line from 45 degree, right? So it is uniform distribution. So if we do inverse of inverse, then this is basically uniform distribution, right? Right. So what we are doing is that first, okay. So no. No, I think it is the other way around. So this is the -1. So this is the u. So if I to the u, this is the I forgot how to prove this. Sorry, I forgot how to prove this. There is a way to prove that. Shoot, this is such a long time ago. So inverse cumulative density function, inverse transform sampling. Yes, it is called inverse transform sampling. Yes, so yes, inverse transform sampling method is first I generate a random number u from standard uniform distribution between 0 to 1 and compute the value of x such that fxu, okay, which is I can take inverse function, I can find this x and take x to be the random number drawn from distribution described by f. So as far as we know the cumulative inverse function of the cumulative density function, then we can generate random number from that distribution, which is called inverse transform sampling. And then this is simply proof. Okay, yeah, this is the proof. I was almost there. Yeah. So let f be a continuous cumulative distribution function. Okay, it is CDF. For normal distribution, it is the integral minus infinity to infinity root 2 pi, something like this. And f inverse is inverse function. So f is, so this is f. And if we flip this one, okay, flip this one to this one, okay, then if we get this to the x, then this is f inverse, right? F inverse with its inverse function using implement because CDF. So you can forget this one. So f inverse u is basically probability that a random number x or under x is greater than equal to u, right? So the thing is that if we pick this number, okay, this one, the inverse of this one, okay, so this one is probability that, so you can ignore this one, probability that fx, so if we pick u over here, so f inverse u means basically fx is u, right? So you don't have to, you forgot infinite, so this is simply equal. You can do this in equal, right? Okay. Then the proof is that u is a uniform random number. So probability that f inverse u is less than x. Okay. So if we pick a random number such that this one is less than x, is less probability that uniform distribution is less than fx. Okay. Uniform distribution is less than fx. Then because from this one, basically this is f, right? This is f inverse f. This is the yeah. This is the uniform distribution is less than this one, fx. So which it should be exactly equal to fx because it is the uniform distribution, right? Right. In the uniform distribution, some number is less than t, like ut is basically t. So in uniform distribution, probability of a uniform distribution less than t is basically t, right? So instead of t, I can plug fx, and then I have fx, right? So therefore, this is exactly fx. So we are done. Okay. So for this is a very general function. F is a general function, so we can generate any number from cumulative density function f using this way. Okay. But this is actually exact way of generating random number. The problem is that this is sometimes uncomfortable, inconvenient, because we have to calculate f inverse. Okay. So this is the good way. For simple normal distribution, it is fine. But if we have a more complicated distribution function, but then it can be too time consuming to calculate f inverse. Okay. Any questions? So let's write down VBA function for this one. Okay. basically I can slightly change it. So norm inverse and norm's inverse is the worksheet function. Okay, so this one. So then I generate like a 10,000, right? 10,000 random number from standard normal distribution. Okay, something like this. Let's calculate average. This is 10,000, so average should be very close to 0, right? But not that close, but anyway. And then variance. Variance should be standard deviation. Standard deviation or variance should be also 1.